On this equation, the most tempting thing is to try to divide both sides by sine theta, but remember that sine theta is a variable, and if you divide by a variable expression, then you're going to most likely eliminate solutions that are valid to the original equation. So rather than do that, what I want to do is to subtract the sine theta and get everything on one side. So I'm subtracting sine theta from both sides, which leaves me a 0 on the other side. Now you see that each of these terms on the left has a factor of sine theta in it. So I'm going to factor that common factor out. And in the first term, when I divide by sine theta, I'm going to get tangent theta. Now I'm not dividing by sine theta to eliminate it. I'm dividing by sine theta because I'm writing it out to the front. If I divide sine theta by sine theta, I get 1, and that's equal to 0. Notice if I multiply, if I distribute sine theta through the parentheses, I get exactly what I have up here, so I haven't lost anything in this problem. Now I have sine theta as one factor and tangent theta minus 1 as my second factor, and I can use the zero factor property that says that either sine theta is equal to 0 and or tangent theta minus 1 is equal to 0. If I draw a picture, and remember that on the unit circle, sine is the y value because sine is y over r, and on the unit circle r is 1, then I can just think about where is y equal to 0, and that is the same answer as where is sine equal to 0. Y is 0 right here at 0 degrees, and again right here at 180 degrees. So I get two answers based on this little equation, two answers for theta, 0 degrees and 180 degrees. Now if I solve this little tangent equation right here, then I'm going to add 1 to both sides so that I get tangent theta is equal to 1. Tangent is going to be positive in both quadrant 1 and again in quadrant 3. So I'm going to get two answers for this. If you use your hand trick in reverse and look at the back of your hand and try to make your tangent equal to 1, which means you need the same number of fingers on the top and the bottom, then you see you get a reference angle of 45 degrees. In quadrant 1, your reference angle is your actual angle. And in quadrant 3, if you have a reference angle of 45, then to get the actual angle, you want to add 180 to it. So 180 plus 45 gives me 225 in quadrant 3. So I get two answers from this little equation. Theta is equal to 45 degrees and 225 degrees. Now neither one of these answers has more weight than the other, so when you have your answer line over here or your answer box on your online homework, then you're just going to list those out. It's conventional to write them in order, but it's not necessary. It should be counted correct, whether the answers are in order from little to big or not. Those are your four solutions. If you graph this to check your answers, then I recommend subtracting the sign to the other side, just like we did right here, and put this expression in your F1, and then look for the zeros instead of looking for the intersections of sine, tangent, and sine. Zeros are easy to find, and sometimes with the trig functions, the intersections can get kind of messy.